Hey there, welcome to today's visual explanation on Pythagoras' theorem. So today we're going to explain why a squared plus b squared equals c squared. There's different kind of explanations out there, but this is one specific one that is fairly straightforward to follow and should be useful for you guys. Okay, so we'll start off with this particular scenario here. We've got a big purple square, and embedded within it is a yellow square there. Okay, what we're doing is we're specifically making the middle square the length c, and the little parts of the sides also a and b. Okay, so there you can see it makes those right hand triangles a, b and c that you can see from Pythagoras' theorem. Okay, now looking at the big square, you can see that each side you just add up a and b, so each side length should be a plus b, and I've put it there in brackets. Okay, first of all, we're going to calculate, as part of this demonstration, I'm going to calculate the total area using the outside lengths. Okay, so that means the a plus b lengths there. Okay, so that area there will be bracket a plus b times by a plus b, bracket a plus b, and that actually equals bracket a plus b all squared. Okay, now this is a quadratic and we have to expand this using that FOIL, or front, outer, inner and last. So there, if we do front there, we get a squared, we'll get ab and then ba plus b squared. Okay, so just to simplify, the AB and the BA add up to 2AB, so we get a squared plus 2AB plus b squared there. Okay, now I've put the 2AB in purple, and we'll come back as to why that's in purple later. Okay, now let's work out the total area using a different method. Okay, so the first method was just with the outside lengths, but we're going to use work out the total area using those four triangles there, or the four right angled triangles there. And we're also going to have that inner square that has side lengths c there, so that inner square within that bigger square. Okay, so now the area of a triangle is half base times height, and given it's a right angled triangle, it's just going to be half times, each of those triangles would be half times a times b, or as you can see there, I've labelled all four of them as half ab. And similarly, c times c, or the area of a square, is just c times c, so it's c squared for that inner square there. Okay, so the total area based on the four triangles and the square, so the square's area is c squared, and there's four of those triangles, so we can say that's 4 times half AB. Okay, so that means the total area, if we simplify that 4 times a half, we'll get the area being c squared plus 2ab. Okay, so 4 times a half is 2, so then we get 2ab. Okay, so we've worked out the area in two different ways. The first way we've worked out using the outside lengths, which is a squared plus 2ab plus b squared, and the second way using the four triangles and the inner square, we get c squared plus 2ab. Now, even though they're two different methods, those two calculations should actually be equal. So we're going to equate them. So what I'm going to say is a squared plus 2ab plus b squared, which is using the outside lengths, is going to equal c squared plus 2ab, which was the area calculated from using the four triangles and the square. Okay, you might see how this cancels out there. If we subtract 2ab off both sides, the 2ab gets removed, and we actually just get left with that famous Pythagoras formula there. So a squared plus b squared equals c squared there. Okay, and that's our little kind of proof or explanation as to why Pythagoras' theorem works. And yeah, so that's all for today. Thanks for watching, and I hope that explained. You might always be like, why do I use this formula? But this is where it comes from here. Okay, as always, if you subscribe to this YouTube channel, it's always much appreciated. And certainly leave some positive feedback and any questions you have below there. Cool. Thanks for watching.